My name is Rob. I work at 1stDibs. I'm a front-end engineer there. If you don't know 1stDibs, it's an online marketplace for very high-end furniture, jewelry, fashion. You should check it out. Yeah, and I've been working with a working group for the past couple of years, championing the spec proposal for defer and stream. And Michael's going to get started.
Yeah, I'm Michael Staib. I'm one of the co-founders of Chillicream, a company building GraphQL tooling, especially the hot chocolate GraphQL server in .NET, and other tools with random names. And I'm also working with Lee and the other TSCs in the working group together. Okay, let's get started. Actually, before we dive into that, all of what we are showing today and talking about is actually what Lee told us about in 2016 at React Europe. So we are still catching up with his, I would say this is actually his master plan of features, and we are still catching up and trying to get them into the specification. Just as a quick recap, so Lee actually introduced things like GraphQL batch, GraphQL subscriptions, stream, defer, and live at this conference talk. We still haven't talked a lot about live yet at the spec meetings, but let's see where we can go with that. Okay, at this point, the stream and defer directives that we talked about 6 years ago are slowly moving into the GraphQL specification. So we are still not there yet. There are a lot of minor details we are talking in the working group about, and Rob will go into the exact problems that we are still working through. I will start to set up the scene here and introduce you to the concepts around defer and stream. So let's say we have something like a trading app where we have an overview of a couple of assets, like cryptocurrencies in this case, and we have a lot of price information here. And we have a couple of very expensive data that we actually need to fetch. Like for this price chart, we want to get some price points. And getting these price points is expensive from the transport as well as from the processing, because we have to get these price points from a very expensive downstream service. And we not only want to get just the price points for this specific cryptocurrency here, we also want to get this for the 5 top cryptocurrencies. So that the user, when he or she just gets to our application, can just swipe easily through the charts. And that is actually where, when we think about this in GraphQL, we hit a wall, because we want to get everything, if possible, in one request. Or that's our ideal thinking. And if we have a GraphQL request like this, we would block our whole UI experience. We would hit refresh or go the first time on our application, start it mobile, and then we would wait, and nothing would happen. But actually, as an engineer, we already have analyzed that the expensive part here is calling this change field here and getting the price points. And this is also where the GraphQL batch idea initially came in. Like what we would do in today's world, we would split the query. We would have a query that fetches the asset details, like name, maybe the price, and then we would have another GraphQL request where we kind of feed in the IDs that we are just fetching to fetch this expensive data that we can do in a second call. And this is actually where we would like to have more control on the client side, because GraphQL is about giving control to the front-end developer, right? And defer and stream allow now that the API consumer can express priority. So which data of my request are actually important to me? But actually, defer and stream are about the reverse, telling the GraphQL server what data is not so important and we can wait a bit for. So in the concrete case, we could take our GraphQL request and mark the change request or the change field where we get the price points as deferred. So essentially telling our GraphQL server to resolve that when there is time. So first get all the other data and then resolve this expensive data and send that down to me as it becomes available. But there's one more thing here. Because I said we are also fetching all the assets so we are fetching the charts for the 5 most important assets here. And that's where we could further optimize our request with something we call stream. And that allows us to tell our nodes field to essentially say, just give me the first asset and then resolve the rest of the assets as you see fit, as they become available. So let's have a look at how this works, because the difference to this talk and Lee's talk in 2016 is that it actually works. Can you see that? Okay. Okay, this is one of our GraphQL tooling that we built at Chillicream. It's Banana Cake Pop, our GraphQL IDE. And I tell you why that is so cool. So this is our initial request. And we could maybe run it. And you can see, kind of takes a second to resolve that. And that is what we would do, like if we just executed that. So if we take the query, decompose it a bit into some fragments that I have here, but essentially the same query. But now I have here the stream directive and here the defer directive. If I run that, you can see I get the first data in 361 milliseconds. That is 3 times faster than my initial request for the first set of data, right? But let's explore that a bit. So I can go here into the logs chart, and then you can actually see that we fetched a lot of patches. So the initial patch, just get that up here. The initial patch just contained like the name of my asset. And then the second patch got actually the second item of my list. Again, just the title here. And then the third patch actually fetched like pricing information. So it's not like there's no order on the back end. The one order that we have is that we don't send a patch down that we cannot apply to the data that we already have received on the client side. But apart from that, the server would send down the data as it becomes available. We could do more here because we deferred like the price and the expensive part, but we can also like do defers and defers, nested defers essentially. So we could put another defer in here. We can see that we now have 20 patches, and then we could optimize that more, and you can already see that now we have 30 patches. So now it would essentially work out the same. We get patches, but more fine-grained. So you can optimize that to your component needs in your application. Okay, let's go back to my slides. One thing before I go back into my slides. So this is actually the actual training application here. Now I have like what I want. I get a fast response of my application, and I just have one GraphQL request. And this GraphQL request, actually you can see here we have a couple of patches, and it uses standard HTTP. So when I show this on conferences to people, they think, okay, are you using WebSockets, or what are you using for that? Because WebSockets are actually difficult to scale, and people then don't want to use it. But this is actually just HTTP, and it will work on anything that you want to use it with, and it's easy to scale. And it essentially works with something like these multi-part responses combined with chunked encoding. But we'll talk on that more in a second. go back to here. There's my clicker. Okay. So from the transport side, what happens is the server would resolve the initial payload. In this case, we get, as I showed you already in our GraphQL IDE, the initial asset with its title. What is new now, if you know the GraphQL response, you can see there's something new, and it's this hasNext. And that indicates that the server has more to give us. So more payloads that we have not yet received. So as more content becomes available, the server will send us like these new multipart sections down as new data patches. And you can see that in the second data patch, we have now a second field here called pass. And pass tells us where we can apply this patch to in our original data. And again, we have more payloads until at some point we have no payload anymore. And that's when we are finished. And the client knows, okay, all the patches were received. And this is really amazing if you use that with something like suspense list, where you now can define in your client applications when which component should be rendered when a certain data patch is coming in. So you can now, but still, I mean, your requests are still as slow as before, but they can appear as if you have literally no loading time, because all the charts that we saw in the beginning that are out of scope, they come in later. But most users will not even see that they are coming in later because you have the appearance that the data is immediately fully available. Okay. We are not stopping here. Actually, we will completely unpack how defer and stream works, and Rob will take us through the GraphQL execution and really show us how the GraphQL execution engine works with defer and stream. You want this?
No, I'm good.
Okay. You want your laptop? Or? Okay.
All right, so I want to spend a few minutes diving into the GraphQL execution algorithm. So if you're a GraphQL implementer, I hope that this will give you a relatively high-level understanding of how defer and stream work behind the scenes, how you can implement it in your server. So I'm going to start off talking about how the execution is defined by the spec today. Then we'll move on to what changes when we introduce defer and stream. So you start off with a function, execute selection set. And a selection set is defined as a group of fields, inline fragments, and fragment spreads that all appear under the same object. And execute selection set is going to take the selection set, pass it to a function called collect fields, which is going to recursively iterate through all of the fragments, inline fragments or fragment spreads, and return a deduplicated list of fields back to execute selection set. And then for every field, we call a function execute field, which that is what calls the field's resolver and gets the result. That goes to a function complete value, which does some validation and makes sure that the correct type of the field was returned. And if the field is a list type, it'll call complete value on every item in the list. And if the field is an object type, it starts this whole process over again, calling execute selection set on the selection set for that object. And then that's finally how you get the completed values for your field. So when we have defer and stream now, we have a new array that we're tracking called subsequent payloads. And we use this to keep track of any defer and stream payloads that are executing as they're encountered. So back to execute selection set, like before, we pass the selection set to collect fields. And again, it's going to recursively iterate through the inline fragments or fragment spreads. But now if it sees a fragment that has the defer directive on it, it's not going to recurse into there. And instead, we're going to call execute selection set on that fragment selection set. And we store this execution in subsequent payloads. So now we've effectively forked execution at the point of this fragment. And we're simultaneously executing our main set of fields and the deferred fields. And from there, collect fields goes and returns the fields back, but now it's not including any of the fields that were on that deferred fragment. And we execute each field again. That resolves the field, calls complete value. But complete value is on the lookout now for any list fields that have the stream directive. So if it does find a list field with a stream directive, it's going to proceed normally, completing the value for each list item up until it gets the index where the initial count index that's specified in the directive. And at that point, it'll fork execution again and push that execution branch to subsequent payloads. And the items that were completed before the initial count get returned back to execute field, and each item after the initial count has its own payload. Then the rest of the execution algorithm continues normally, and any of these other subsequent payload executions, as they're running, they could be running into more deferred directives, more stream directives, and that will push more of these execution branches back onto the subsequent payloads list. Then after the initial data is done, we have a new function in the spec, yield subsequent payloads, which handles sending results to the client. So first, it'll send off that initial payload, and then it will check which of the subsequent payloads are ready. And so we keep track of dependencies on those. So we make sure that a stream list the list items aren't sent out of order, or if a deferred fragment isn't sent before its parent object is resolved. But other than that, it's just, as soon as it's ready, it gets sent over to the client. Yeah, so now, after going over the execution, I want to talk a little bit more about what our process has been for this proposal. It's a pretty large and complex proposal, so we created a dedicated repo to keep records documenting all of the decisions that we've made. And so each question, discussion point, or issue has a top-level GitHub discussion. I think there's over 40 of them right now. Just writing it up in a format of a pattern called architectural decision records, where we'll explain the background, context around an issue, what decisions we made with the working group, the consequences of those decisions, and the current implementation status. And I hope that this is a valuable resource going forward that can be preserved, and we can always look back on why we made the decisions we did. And if you're working on another large spec proposal, I think you can take a similar approach. And I just want to highlight, for the rest of the talk, I just want to highlight a few interesting topics that have come up while working on this that we discussed with the working group and the outcomes. So as we showed earlier, we have each payload has a Boolean field, hasNext, and this is used by the client to know if more payloads are expected. And it actually started out as a field called isFinal, and that would only be on the final payload. But we found that caused backwards compatibility issues, where if a client is communicating with a server that doesn't implement defer stream, it's not going to see that isFinal because it's not in the spec as it is today, and it'll get stuck waiting for more payloads. So we decided to inverse it, call it hasNext, and so another thing with hasNext is that when you have an async data source, like an async iterable, you may not know if there are going to be any additional list items until some time has passed after the final one has been sent. So for this use case, we allow a payload containing only hasNext false, no data or any other fields. And when your data source eventually does indicate there's no more items, you could send that to the client and they know to close the connection. Another thing that we talked about for a while is we only allow the defer directive on fragment spreads and inline fragments. The first experimental implementation of defer was in Apollo server, and that supported defer on fields. And at 1stDibs, we were trying that out on our code base, and we found that most of our use cases, we wanted to defer a group of fields. And when you defer this group of fields, you want to block the entire UI from rendering until all the fields in the group are resolved. So your two options there are either your client is going to track the loading state of each of the fields, and that gets kind of messy, or alternatively, you can just keep updating as they come in. But that's not good either, because now your UI is repainting and reflowing as each of these fields come in. So by supporting defer and fragments, the client is signaling to the server to return the results of the fields in the fragment when the entire fragment's finished executing. And the client only needs to wait for this fragment's payload to come in, and it really works well with React, where you are saying that this fragment corresponds to this component, and when its data is ready, you can render it. I don't think that defer on fields is ruled out entirely. We're not considering it for our proposal, but if any other use cases come up, that's something that could be proposed in the future. Another topic that we spent a lot of time on in the working group meetings is non-null propagation. So the GraphQL spec requires nulls on non-null fields to bubble up to the next nullable field. So how do you bubble up to a field that was already sent to the client? You can't go back in time and change what was sent. So we decided that defer and stream are going to act as null boundaries. And so I'll show a few examples to explain what that means. So first, defer example. In normal cases, the data field on the payload from a defer directive is always going to be an object. That's because you can only do it on fragments. Fragments always have a selection set. So we can use this to our advantage, and we can let a null data field represent an error that should have bubbled upwards. So in this example, we have a deferred fragment on this person field, and that has the home world field declared as non-null on the person type. But in this case, the resolver either errors or returns null in this field. If this wasn't deferred, that null would have bubbled up to the person field. But because it was already sent to the client, we will send the client a payload with the errors, and data is going to be set to null. So with stream, we originally said that the data field on a stream payload would just directly point to the stream list item. And we decided instead that we're going to wrap the stream list item into an array. And that allows us to differentiate between a valid null result and a null that originates from an error, which would have bubbled up. So in this example, the heroes field is a list of non-nullable object types. And we'll say that the third result errors. And so what happens is the initial payload sent normally. The second payload returns the second list item wrapped in an array. And the third payload returns the errors field populated with the non-null error, and data is entirely null. And so if the type of the list allowed null fields, it would have returned an array with a single null value. So with both defer and stream, it's whenever a client sees this data field set to null, they're going to know that that null should have bubbled up higher. And so the spec's not requiring clients to handle that in any specific way. It's just describing what the behavior is, and clients can implement whatever makes sense. Yeah, and we also talked a lot about batching. We want to keep our proposal small, so I don't think that we'll include batching in the initial spec, but we are thinking about how it could be enabled later. We want to ultimately just make sure that any decisions that we make now aren't going to make it harder to implement batching in the future. So a few things that we've discussed are you can batch with stream. So since we're already returning a data array on these payloads, we can just put multiple list items in there. And that could be a more efficient way to deliver large lists. Or another approach is that we could just return batches of the entire payload objects, where the GraphQL server will just yield arrays of the payload format that we talked about. And this has the benefit of being able to return batches of both deferred data and stream data from any field instead of just the stream data from a single field. Yeah, and so that's all that I have. I hope that that was a good overview of defer and stream, a little bit of why it took as long as it did. And I encourage you to check out the discussion repo. There's examples in there, how to get started, and feel free to start new discussions if you have any questions, feedback, concerns. Yeah, thank you.
Other questions or?
Yeah.
Caching implications with that multi-part jump response, or is this what non-null?
You mean like over CDN or?
No, just HTTP caching.
I mean, it's a stream, so could be a huge response that you get, and so on. So there might be implications. Depends on your scenario, essentially. But in the end, it's just one.
Just a response
Yeah.
at the end of the day.
It could be, though, that if that response is cached, and then you're probably not going to want to just iterate through all those payloads in that cache response and thrash your UI rendering them over and over. So I think that's something to be aware of. Yeah?
What are your thoughts about different streamlines? I saw the discussion first, but it seems like it's not when it was useful or not.
Yeah, I think we do have it supported in our proposal. I think it could be useful in cases like in Relay, you might have a subscription where you're putting a fragment on that subscription that corresponds to some large UI component. That component could have, that fragment could have a ton of other fragments underneath it. There could be defers and streams in there. And I think that it would all work. The way we have it, it's additional payloads get sent over that same connection.
Yeah, I think the main difference for subscriptions is in subscription you aim for smaller results, like only the things that really change. So you want to have incremental small messages because that could be a high frequency. You have a high frequency there. So while it's possible, in most cases you have stream and defer on standard HTTP requests in GraphQL, like query or mutation. Like it will work with any operation type. Like also we talked about mutations, and there are some limitations in mutation because we cannot defer the root level, essentially the mutation itself. There was at least one discussion point we had.
We don't allow defer on the actual root mutation field, but it does work in the fields nested under that, yeah.
Exactly, because in mutations, like the top level field is the mutation, so in the GraphQL spec, we have this sequential execution there, and putting defer on that would essentially change the order. But on the lower level fields, these are essentially queries on the changed state of our server, so we can put defer in there. So there are a couple of limitations depending on your operation type, but in general, it's possible.
With subscriptions, the payloads are coming over the same channel as the actual subscription events. So that hasNext field could be used to, after you get a hasNext false, the next one is going to be the next subscription event and they get queued up behind. You're not going to get a patch from a subscription payload that comes after like the next event, if that makes sense.
Does that mean that there's some danger to adding defer string to a subscription, given you could end up blocking, especially if it was a string, you could end up blocking future subscription responses?
It might be, but it shouldn't really block it because you could have the same situation without defer and stream. If your resolvers take a really long time, then those subscription payloads are going to get backed up. This, it really should only mean that you're going to get the non-deferred and streamed parts of the payload sooner.
Yeah, and I mean, if you have such expensive fields on a subscription in the first place, it could even block without defer. I mean, essentially the same, because like in subscription you have like your event stream that essentially triggers the same query engine to execute your request. So it like there's no overall additional complexity. It's just that you have to think about high frequency there. So having very expensive resolvers in a subscription would be counterproductive in many cases.
It was relatively straightforward to implement in GraphQL.js. It was kind of just one async iterable that you're getting the subscription events, and that event could give you another one that's giving you the defer and stream. So it was kind of just send that one out, drain this one, move on to the next one.
Yeah, I think one of the really exciting things is that you actually can use all of this today. Like if you take Relay, if you take the newest version of React, then you can use suspense lists, you can use stream and defer with Relay. There are packages, 2 packages for the transport already that you can plug in. So it all works. What?
That's my
Okay.
yes, definitely.
Yeah. But so it's the right time to get started with this, Paul. And I mean, still, maybe for production, you don't want to use it there because there could be spec changes, but you can play with it. It's a difference to 2016.
Yeah.
There's some ways sort of summing up with live directives.
So at the moment, we don't discuss it in the working group. I mean, there were approaches towards live. There are also a couple of experimental implementations out there. I mean, all these ideas actually spawn so many community experiments, but it always takes like, to get it really into the spec, you need a champion that really cares about, like in this case, Rob is doing a lot of work for the last 2 years on that spec proposal. So you need somebody who cares about, for instance, live, and says, I want to solve these problems, and I push that, and I direct people that also want to work on that. So, with defer and stream, we had this push. Actually, there were also people from Facebook in the beginning, and your colleague also was working on that. So there was a big push, and Rob is keeping a track of all and pushing it along. So if you want to get something into the GraphQL specification in general, you need to champion your ideas. Otherwise, nobody will care.
Yep.
Is there a use case to time-bound stream, meaning kind of an alternative subscription? Allow it to work for 5 seconds, so if you're free data, it could also.
So it's an HTTP. So it's essentially depends. When you do it over subscriptions, it's not HTTP. But in general, like if you use it on query or mutation, it's an HTTP request, and it has the same like timeout boundaries that you have with a standard HTTP request. But if you set that to
We want to keep subscriptions for these long-running events and stream more for lowering the time to interactive of getting those first few list items.
exactly, it's for deprioritizing like data that you want to have, but that for the first interaction with your front end you don't need. That's the main use case.
You know, some procedure on a difference in the network
So I showed that, like just from the timing for the first for the first payload, you have a huge reduction in time, and the overall overhead for this multi-part request is not so much. So it's actually not so worth discussing the overhead in the multi-part boundaries and stuff. Apart from that, it could be that the overall request actually takes a bit longer because we spawn it off. It also depends on how you implement your execution engine. What we did in Hot Chocolate was like you can decide if the subsequent payloads only start processing after we wrote the initial payload into the output stream, but you can also decide to start processing these at the same time. It depends on your strategy that you have in the backend. There's also like the option that is still being discussed, so that the execution engine can also like choose to skip the defer directive. It's not recommended, but for advanced use cases, it could be that the server says, "Oh, you're just deferring here scalars, leaf types that we anyway have already in memory. So why defer it? We just send it down, right?" As a specific note in the specification as of yet, but
That also makes it backwards compatible.
yes,
Yep.
exactly.
If you ignore all of them,
Yeah, then it's just I support it, but I ignore it. You see, it's more reason to keep it in.
What's the reason? Like, if between this, which so-called, if you have some network and you have some kind of background or some kind of recovery.
So the question is if, like, we receive an initial payload and then the connection is disrupted.
Yeah,
Yeah.
and you connect it, like, you connect the things, but you have some gap between
Yeah.
them, can you resend some package that was
Okay, I think there's a, so let me say two things here. So the GraphQL core specification doesn't care about transport. So it's, there we don't actually care about these transport specifics. But there is the GraphQL over HTTP spec where we are specifying these kinds of things. And like in this particular case, we have an HTTP request. So if the connection is disrupted, we just don't get any more payload, and then we get an HTTP error in this kind, and then the client can just reject everything, like throw an error or something. So there is no problem like with package loss.
We don't have like built into the spec for the execution to have some kind of way to resume like a partially fulfilled connection.
Any more questions? Okay. So you can reach out to us if you have any questions. Also, the working group is open if you want to engage. It's always good to have a look. And there's also like these discussions. Each working group meeting is actually put on YouTube. It's daunting to look through 2 hours, but if you can skip through your topic and then we watch how the discussions work around that. So, thanks.